Hi everyone, Dragonfly Rising's School of Data proudly presents the AI Demystified for Executives podcast. This is the podcast for executives who want to learn how to apply AI to their business. I'm your host, Andrew Psaltis. I've been in the data and AI space for over 25 years. All of this technology gets me excited, but I find even more enjoyment in teaching others and helping them understand how to apply it to their business. As a reminder, this podcast is split into two parts. 7-minute Mondays, perfect for catching up on the week's most important aha moments during your commute or while sipping your morning coffee or tea. And then 30 to 40-minute deep dives into the week's topics on Wednesday. That may be a bit much if you're driving. Be sure to subscribe to this podcast on your favorite platform where you listen to others. You can also subscribe to my newsletter so you never miss an update. The address is in the show notes. Without further ado, let's dive into this episode. This week's topic is an introduction to neural networks and why, as a business leader, you should care. So, what are neural networks? You've probably heard the term before. They often compare them to the human brain, if you remember back from biology classes, is composed of neurons that are connected through synapses. So let's build the world's simplest neural network. Imagine for a moment that you're wanting to predict the price of a house based on the size. So the simplest thing we could possibly do, we want to say, based on the size of a house, we want to be able to predict the price. If we had the size and we want to predict the price, we would create a function that does that prediction, that takes the size and outputs the price. Okay, so that's the simplest neural network you could possibly build. Take one input, size, and one output, the price. So that's a single neuron neural network. Now, things often become much more complicated than that. So what you do is you take this simple size, predicting price, and we start to do what's called stacking them. Start to have more variables. If you are buying a house or trying to predict the price of a house, let's say that we have the size. Another attribute that's probably important to you is the number of bedrooms. From the size and the number of bedrooms, then we could figure out, based on our family size, will this work for our family? Whether you're 2 people, 4 people, 6 people, will the size of it, square footage, square meters, number of bedrooms, work for your family size? Then we may want to consider the zip code or the postal code. That may give us the walkability to grocery stores or to restaurants. And maybe we look at the overall income level in the neighborhood. We're using that to try and understand the school quality. At least in the U.S., oftentimes there's a relationship there between the neighborhood income level and the school quality. So now we have the size, the number of bedrooms, the zip code, and the income level of the neighborhood to try and produce the price. So say the size is X1, number of bedrooms X2, the zip code or postal code X3, and the income being X4, and we're trying to produce the price. This would be a neural network. Functions you would think about in the middle that I mentioned of family size, walkability, and school quality, that is what's called a hidden layer in a neural network. The X, we have 4 X variables: size, number of bedrooms, zip code, income. Then there's a hidden one of these functions where there's the family size, the walkability, the school quality, and then the output is price. So again, we have X being all of our variables and Y being the price. We've now built this network. The next thing you do is give it a lot of data that has the X variables, the size, number of bedrooms, the zip code or postal code, and the income, and the price. So we give it a lot of data that we have X and we know Y. This is called supervised learning because we're supervising it and giving it data of all the X and all the Y. After the network is trained, it could then be passed X values, size, number of bedrooms, zip code, and income that it has not seen before, and it will predict the price. We have input layer, the X's, hidden, the family, size, walkability, and school quality, and then the output layer price. So a really simple neural network. Our neural network had one input layer, one hidden layer, and one output layer. There are many hidden layers. The term deep learning refers to how deep those hidden layers are. Instead of having one, like our example, there may be 10, 20, or 50 layers. GPT-4, which is what's behind the most current version of ChatGPT, has 120 layers, so extremely complex. You use these neural networks all the time when you use ChatGPT, when you use Siri, when you use Alexa, if you've used Google Translate. These are certainly not without their challenges and limitations. You hear all the time about the amount of compute that's required and the amount of data that's required. It's a tremendous amount of computational power required to do this. And it's really hard to explain how it reaches its decision. It's a black box. And it ends up oftentimes with bias and fairness issues because, again, it's reflecting the bias in the data it's trained on. So why should you care as a business leader? This is all great. Get it. You understand the basics of it's a function that goes from X to Y, and now you're just having many layers of these functions. But why should you care? When you think about this driving like competitive advantage, better customer experience. So they're used for powering chatbots, virtual assistants, recommendation engines. Netflix, Amazon, they're using these neural networks to increase your engagement. You may be able to unlock new revenue streams, predictive analytics tools, automating fraud detection. Neural networks are no longer just a concept for data scientists and tech enthusiasts. They're really transforming industries and shaping customer expectations. Tune in to the Deep Dive Wednesday episode where we explore these architectures more in depth. That's all for now.